Okay, we're going to do two more types of approximations. One is going to be another rectangle, but we're going to use what's called a midpoint rectangle. And we're still going to use two rectangles here. So the function again is still this x squared plus 1. So the width of the rectangle is still 1, but this time I want to hit the curve in the middle. And that's where I'm going to get my y value for the rectangle. So there's my first rectangle. So notice the width of the rectangle is 1, but the y value is going to be f of 1.5. It's in the middle of 1 and 2. Second one, same thing. I want to hit it in the middle and go straight across. There's my second rectangle. Width is still 1, and this one would be f of 2.5. And if you punch these out, I believe this is 3.25, this is 7.25. So area using a midpoint is 10.5, and notice that this is a better approximation than using a left or a right because you have a little bit above and some below. Okay, last type of approximation we're going to look at is what's called a trapezoidal, and it's exactly like it sounds. We're going to use trapezoids. So you do need to recall the formula for the area of a trapezoid. So if you remember, the area of a trapezoid is 1/2 times the height times the sum of the two bases. Okay, so again, this is my region. I'm still going to use two trapezoids. So let's draw our first trapezoid. So our first trapezoid looks something like this. Okay, so we've got 1/2. The height of the trapezoid is just the width, right? It's like a trapezoid on its side. So the width is 1, and then these two pieces are going to be my two bases. My first base, notice, hits it at 1, so that would be f of 1. The second base hits it at 2, so the y value would be f of 2. So I'm just using this trapezoid formula to get the area of the first trapezoid. The area of the second trapezoid is this piece right here. So 1/2, height is still 1. Notice the first base is at f of 2. The second base is at f of 3. So there's your second trapezoid. So if I can find the area of those two trapezoids, that will give me the approximation. So if I do this, I've got 1/2 times 1. F of 1 ends up being 2. F of 2 is 5. Then my second trapezoid, same thing. I've got 5 plus 10. And this ends up giving me 11. Okay, notice here, this is probably an even better approximation than any of the rectangles. And if you can see, this does go over a little bit of the curve. So this is an over approximation as well. And the reason is, if anytime you have a concave up graph, when you do a trapezoidal, the trapezoidal will always go a little bit above the curve.